In the previous video, we have seen how FDMA, TDMA, CDMA enhance the capacity of wireless communication system. Today we discuss further about how a larger area which is divided into smaller area which is known as cell, how small a cell should be, and what a kind of capacity improvement are possible through the repetition of the available frequency. If we talk about all kind of technologies together, then I should use word wireless resource rather than wireless frequency. The wireless resource means, if we talk about GSM, we may have a different frequencies and different time slots that ensure a different user. For example, a user communicating with this particular tower is having one particular frequency, one particular time slot of that frequency. The same frequency can be used by number of users. Other frequency can be used here, can be used by number of other times. So in this particular area, the frequency division multiple access and time division multiple access is used. So as and when user demand a service, he will be provided one time slot of one frequency, and that is the wireless resource for that particular talk. So that is usually done in GSM. In CDMA, the particular resource means user need a code on which he can communicate with the particular tower. So in CDMA, wireless resource is a code. In GSM, the wireless resource is frequency and time slot. So the same frequencies, same time slots and same codes are reused by specially separated base stations. This way we can improve our channel capacity. Here if you see the same color cell, that means the whatever frequencies are used here, the same frequencies are used here. In case of CDMA, whatever codes are used here, same codes are used here, and they are specially separated so that the signal power from this BTS, this tower, must not reach to this particular area, and signal of this tower must not reach to this area. And that's why we can subdivided the available area into number of times to avail the capacity as per the user increases. So this is the one way, and that is referred as frequency reuse. When we have done about the frequency reuse, that means we are dividing our larger area into the smaller area, then there is a quite possible situation generates when mobile user is on particular speed moving from one cell to another cell, and his talk is continue. But what happened here, if you see, when the user is moving from one particular cell to another particular cell, he will lose the connectivity when he is entering into this area. That means now the power from this particular tower will not suffice that the sensitivity of mobile would work there. And so this situation need some sort of technological assistant, that is known as handoff. A switching technique called handoff enables a call to proceed uninterrupted when one user moves from one cell to another cell. That means user must not be aware about what is happening. There should be no such sound, no interference, nothing has been done. User must enjoy the service during his call. So this is the theme behind handoff. So handoff word itself represent, it will something which changes from one cell to another cell. Let us see the procedure. Here there is one cell this is another cell. Here one mobile station user is there, one another mobile station user is there, and the communication between mobile tower to mobile station are usually referred by the bidirectional channel, that is full duplex communication. So in the full duplex communication, whenever we received signal from BTS tower, it is usually referred as a downlink channel. Whenever we transmit to BTS tower, that means uplink tower. So mobile phone to tower uplink and mobile tower to mobile phone is downlink. This way we are connected and we are able to talk bidirectionally through mobile tower. Suppose this user is in the communication and is in speed also. So usually he becomes near to the newer tower. He is moving in this particular area, we suppose, thinking like this. So whenever this user moves from this area, again I am just refining this, when this user moving from one cell to another cell, during that he need a process, so that now this frequency pair which was connected to the parent cell is now switch over to the frequency pair of the newer cell where this user is entering. So the handoff process is nothing but a handoff wireless resource, a frequency pair from one cell to another cell without knowing user, and user must enjoy his talk during this time also. So this process need a lot of measurement, a lot of decision. So we'll discuss in the coming lectures how handoff has been done, how the handoff requirement has been measured, and what happen if the next station there is no any frequency, and so a lot of thing to discuss that will be in the coming lectures. So this is a handoff process that need to be designed in the wireless communication. One more aspect we have to look in the wireless communication, that is how to assign channels to the cell. If we take the case of 3 cell frequency reuse, that means our all frequencies must be divided into 3 particular cell and it can be repeatedly used further. So there are 2 type of assignments, one is a fixed channel assignment and one is a dynamic channel assignment. Here if we see the dynamic channel assignments, we are having 9 frequencies and 9 frequencies we are going to assign into the particular cell. So this is the starting point of the sub channel allocation. That means whenever in cell A, if any one user has demand, then the frequency number 1 is assigned to it. If in cell B any one user has demand for a call, he will be assigned channel number 7, and in C if any one user has demanded, he will be assigned channel number 4. Here you can see the greatly separation of the frequency 1, 7 and 4. So the adjacent channel interference, that means the nearby frequencies may be create interference due to if filters are not very sharp. So if first users are demanded, the separation of frequency is being considered. When the same users are in communication and another user has demanded in the cell A, B and C, then they will be served like second slot, 8th slot and 5th slot. So it has been considered till 3 users in each cell has asked for the service, there can be a great separation of frequencies in each. Now when the new user, say user number 4 in A has demanded the service, so what to do is all depend on mobile service provider. That means if a talk of one first user has been completed here, or he is in used, even though whether what kind of separation is provided. So in dynamic channel assignment, each frequency, 9 frequency are assigned like this. Then again 9 frequencies can be assigned again like this, and again it can be assigned like this. So in any slot, if you see, there is a great separation between the users. So the adjacent channel interference will be as minimum as possible. And if there are more number of cell in a cluster, so what is a cluster? Total number of frequencies are divided into number of cell is known as cluster. Then the repeating cells are repeating frequencies in the different areas, that means cluster repetition. For example, in this area total frequencies are assigned in this particular 7 cell. So for example 21 frequencies are there, so each cell will have the 3 frequencies. Now the same cluster will be repeating. So your capacity of users will be increased to serve. As many cells you are dividing, that means more capacity you are enhancing. So if further more users are there, you can subdivide this area into smaller cell. So cell size must be small and small. So that is the result today when we see around the n number of mobile towers we are observing at every half an hour, every half an kilometer distance, or every 1 kilometer distance, which was observed 1 or 2 or 3 towers earlier in a city before a decade. So the greatly improved capacity in a last decade by increasing the frequency reuse as many times as possible. And in last, in this video we'll consider one important conclusion. Usually in any wireless system, the performance of system can be improved by improving signal to noise ratio, but in GSM it is not true, because when we are increasing the signal power, that means we are increasing the noise power of the same frequency used somewhere. The co-channel interference means the frequency used in one cell, the same frequency used in some another cell of the another cluster. So if I am increasing the signal power just to enhance the performance, that means I am increasing the noise to the frequency reuse cell. And so in GSM this statement is not true, that performance can be improved by improving signal to noise ratio. So power regulation in GSM is very much important in the cellular phone, and so dynamic power is used for that. In one particular second, 800 times the power transmission level is being monitored. As user moving away from the tower, he will transmit more power. When he will supposed to be near to the tower, he will transmit less power. So in a cell, when user is moving, he need some minimum power level between mobile tower to the mobile. So that will be ensure the minimum level strength, and as per the class of the power level will be changed by the position of mobile user towards the tower or away from the tower. So power level measurement is very important. In the next talk we will discuss further about the how frequency reuse further enhanced by various techniques, how to increase the capacity like cell splitting, cell sectoring, and microcell John concept. Before that, we would like to discuss also about one of the important parameter of wireless communication, that is handoff and handoff related measurement. Thank you.